Bad splice connections are the #1 failure point of every low-voltage lighting system, from needlessly cut wire strands that create voltage loss at the splice, to water-corroded and unsealed connections, to poorly connected wires that eventually melt or simply come apart. Low-voltage lighting creates amperages in the wire that are 10 times that of a comparable 120-volt system. High amperage is what melts wires and is where the systems fail. A bad splice connection causes resistance, which generates heat at the wire splice connection, potentially melting and failing over time. This video demonstrates a crimped and heat shrink waterproof wire splice connection for a 4-fixture, 2-fixture, and single splice made on a 12-gauge wire from the power supply. First, let's go over a few tools we recommend for a strong, stable wire splice connection. The wire stripper that we strongly recommend is the cast lighting model CASTRIP1, which is fitted with a custom blade set for 18-2, 16-2, 14-2, 12-2, and 10-2 low-voltage stranded wire. Note: if it's cold out, use a heat gun to soften the insulation before stripping the jacket off the wire. The heat shrink most often used for fixture wire installation is the 1/2-inch clear model CHS1250C, which is sold in packs of 50 feet, provided in 2-foot sections, custom made by Cast Lighting, with twice the amount of internal sealant than you will find in other products designed to seal out moisture. The barrel butt crimps splice connections are 12-10, model CLWSB10B, non-insulated, seamless, tin-coated barrel crimps. The crimper tool is model CCRIMP. This crimper features a ratcheting style, which forces the user to fully compress the crimp before it will open back up, ensuring the correct pounds of force are applied to remove air from the wire strands and fully solidify the wire with the barrel crimp. This produces what we call a mechanical soldered connection, which eliminates resistance, provides a nice, clean path for electrons to flow down the wire. It is extremely important that the small wire strands are not cut when removing the insulation during a splice. The loss of any wire strands must be avoided at all costs because cut strands increase wire resistance. If you cut 5 strands at each splice, you can reduce the wire gauge at each splice and end up with a 16-gauge wire when you paid for a 12-gauge wire, which may not deliver the necessary voltage at the end of the wire run. In this example, I am starting with about 7 inches of heat shrink material. I am going to cut 2 pieces for our connection and set them aside. From there, I will cut and split the wire. Once the wires are split, I'll take one side and slide the heat shrink over it and use wire strippers on the ends of the wire. That's for one side of the connection. Then I'll take the other side of the wire and remove the material from each end with our easy wire stripping tool. We're working with a mix of 12-gauge and 16-gauge wires in this example. Now I will insert the wires into the barrel crimp. Ensure the 12-gauge and 16-gauge are aligned properly. Crimp it down securely. Next, position the heat shrink so it's centered over the connection. Start heating from the center, working your way toward one end. You want to see the lines in the center disappear. That tells you it's properly shrinking. Once you see a bit of sealant at the end, it means you've applied enough heat. Now move to the other side and repeat the process. Watch for the little lines on the heat shrink. If they're still visible, it means you need more heat. The heat shrink should pull back, sealing the connection fully. That's how you know you've got a perfect bond. No air, no gaps. On this connection, we're going to illustrate doing a 4-fixture connection at a singular space. In order to do that, you need our SB8B. This is a number 8 seamless barrel crimp. So what you have to do, like the other illustration, is you need to cut and splice your wire. For a 4-fixture splice, we'll use a number 8 seamless barrel crimp. Start by splitting the home run wire. This is your main 12-2 feed wire from the transformer. A tile snip works great to separate the wire without damaging the insulation. It is not recommended to use a razor knife as it may cut into the insulation. Slide an 8-inch piece of 1/2-inch heat shrink over one side, then feed in the wires from each fixture. Line up all wires flat, no twisting, and insert every strand fully into the crimp barrel. Crimp down using the number 8 setting on your tool. Repeat on the other side. Position the heat shrink centered over the connection. When applying heat, wear gloves. The connection will get hot. As the heat shrink softens, massage and twist it to spread the internal sealant around the wires. Work from the center outward to avoid air pockets. When the heat shrink pulls back and sealant seeps out at the ends, that's your sign it's done right. This method creates a mechanical solder-like bond, strong, sealed, and reliable. It's the best way to avoid failure, unlike wire nuts that loosen over time. For single fixture connections, the process is similar. Use 9-inch pieces of heat shrink, split and strip the wires, and crimp with a 1210 barrel crimp. Always make sure every strand is inside the crimp barrel before securing it. Heat from the center out, avoiding air pockets. Watch the shrink pull back and the sealant release. That's your perfect connection. From this crimp connection back, we have one piece of 12 gauge and two pieces of 16 gauge wire. We have the external insulator and inside is our internal sealant. Our objective is where all the red is. We want to make sure that the sealant makes its way in all the spaces. We don't want water to be able to seep into the barrel crimp. It's important to make sure that there is an internal sealant between these wires. Where there is a V shape, there's a natural V where each wire rests on each other. That's why we have this material custom made with an excessive amount of internal sealing. We are going to show you what it looks like internally by cutting this wire in half. In the end, these heat shrink crimps ensure long-lasting, waterproof connections. They stand up to weather, heat, cold, and time. No callbacks, no failures. The only way this will fail is if someone cuts it with a shovel. When we cut the connection open, you can see the internal sealant completely filling all the gaps. That's a bulletproof splice. No water's getting in. And that's how you make a waterproof and durable heat shrink connection.